So hello and welcome to the first tutorial where we will be getting started with tasks. So we will start by creating a static list of tasks that we will be storing in memory. So we won't be using any databases or repositories or things like that. We will be learning about these things in the future, but right now we will focus on just the simple in-memory implementation. And then we will create two endpoints. So an endpoint for getting a list of tasks and an endpoint for getting a single task by ID. In the process, we will be learning about models or entities. We'll also be learning about one of the most important principles in object-oriented design and clean code architecture, which is the single responsibility principle or separation of concerns. We will also touch upon another very important principle, which is the inversion of control principle or pattern using dependency injection. And we will see how Spring handles it using the auto-wired annotation. Last but not least, we will learn about exceptions and how we can map exceptions to proper HTTP response status codes. So let's get started. To keep things clean and tidy, we will create a separate package for tasks, and in here we are going to create our model class, which is going to model a task. And if you remember from the individual project module, the task object is just the data structure that represents the task. And in the context of model view controller architecture, the task is going to be the model in that scenario. And depending on the application, the model could be a lot of different things. It could be the project, could be the task, it could be the user. In the context of a to-do application, maybe for a social platform, that could be a post, it could be a friend, a group, a chat group, a game, it could be a lot of different things. So we're gonna keep it very simple. We're gonna have one field to represent the name and another field to represent the date. I know it's better to use date objects to represent dates, but just to avoid writing a lot of boilerplate, I'm gonna use a string to keep it simple and focus on the Spring related aspects of the project. One additional field that is very common to add is basically an ID field, an identification field. And every model needs some form of identifier to be able to distinguish between different tasks, and that field has to be unique. And usually there are two different type of IDs used in databases, either UUIDs or just simple integers. In that case, we're just going to use simple integers to make things a bit simple. So private, long, and ID. And it's also common to call it ID. And long is just a big integer. We're going to also add a constructor. Let's create a default constructor that doesn't take anything, and maybe another constructor that takes all the fields. Let's generate some getters and setters as well for everything. So awesome. Just a simple model, simple task class. So right now, to be able to interact with that class from an HTTP client, what we need to do is create a controller class as well. So the convention in here is to use the name of the model or the name of the resource, which is task, and then controller. And we need to tell Spring that this is a REST controller. so that it can look into the different methods and different request mappings when it handles HTTP requests. And as we've said in the beginning of the video, we're going to do two things. So we want to get a list of all the tasks, and we want to basically get a specific task by its ID. So let's start by adding a static field to represent the task list. So it's going to be a list of tasks. Let's call it task list for simplicity. Let's import the class. And to start with, let's just create a new array list that is empty. So let's start by implementing this method. So it's gonna return a list of tasks, and let's call it getAll. And in here, the only thing that we need to do is just return the task list. But as you remember, if we don't specify the request mapping, Spring doesn't know where to forward an HTTP request to get the tasks. So in here, we're going to add the request mapping annotation. And as the path, we can actually write anything in here, but it's a convention to use the same name as the model, but lowercase and pluralized. So we're going to use tasks. So let's see if that is going to work. So we will rerun our application, and then we're going to open the terminal or the web browser. You can either open the terminal or web browser. I like using curl. So curl localhost, specifying the port 8080, and then the path, which is the same as we have specified in the request mapping. So tasks. And as you can see, we've got two square brackets, and this is basically an array in JSON. So JSON is this JavaScript object notation. It's probably the most common data exchange format, and that is human readable. And in here, you can basically define an array of anything. So it could be an array of numbers, an array of strings, an array of objects. It could be an array of anything. If you're interested, you should definitely learn about JSON if you're not already familiar with it. But it's a very simple and intuitive and flexible data structure. So in the background, Spring is smart enough to convert this Java list into the JSON implementation. So that's actually very cool. But let's see if it works also if we have some tasks inside our static list. So let's create a static block where we will be adding some simple dummy tasks. So we're going to create a new task, and first we're going to provide the ID. So let's start by 1, and this is long, so we need an L in the end. And then the name, so name 1, and some date, and 2020-01-01. Let's create a new task as well. Just make sure that the IDs are different. Maybe change the name as well, and date. And we're gonna need to restart the server. And right now the server has restarted, so let's see if it's gonna work. And indeed. So as you can see in here, Spring has converted these tasks, the task class that we've defined in here, the task model, into the JSON notation. So as you see, we have an object, and in here we have different fields of that object. So we have the ID, which is an integer, which is 1, and we have the name, it has the correct name as we've provided, and so on and so forth. So we didn't need to do anything to do that. Spring has done it automatically. It has converted these task Java classes into JSON format automatically. So that is pretty cool. Let's see if we can also get a specific task by its ID. So we're gonna have a method that returns a task, and we're gonna call it get by ID. And in here we are going to return some task. So just to test it, let's return just a new task that is empty, has no values. And we need to map it to a certain path. And the convention in here, when we use RESTful controllers, which we will be discussing in more details in the lectures, is that the format is that we use the same resource name, pluralized resource name, as for getting all of the tasks, but we add a path variable which is going to specify the ID. And then we can use that ID that we pass in the path as a path variable in the method to access the task. So in here we're gonna have a long ID, and to tell Spring that this is a path variable, that the source of this parameter is the path variable, we just need to use the path variable annotation and make sure that we have the same name. So that means if we go to that path and specify an ID, we should be getting right now an empty task, which we're going to fix later. But let's see if the routing layer works. So if we go back to the terminal, so if we get just tasks, we will be getting a list of tasks. But if we go to tasks / and instead of this ID variable, we just specify some dummy ID, we will be getting an empty or a null task, an empty task, because we haven't provided the ID, the name, or the date, or anything. That's probably not what we want to do. What we want to do is we want to filter through the task list and basically get the task that has the same ID as the one that the user has provided. So let's see if we can do that. So what we're gonna do is we're gonna take the task list, and I'm gonna use the stream feature of Java 11 just to make things a bit more readable and clean. So we will filter basically by ID. So we're going to take a task, and if the task ID is the same as the ID provided, or let's use the equals just to make it a bit cleaner, equals to the ID provided by the user. So if the task's ID is the same as the one provided in the path, then we want to get it. But imagine the case where the task list doesn't have an ID that is equal to the path variable. So maybe the user has entered 3, and we don't have a task that has an ID of 3. So basically the Stream API is going to return an optional type. And basically an optional type, so if you go Java optional, it's basically a generic type which represents a value that might exist. So we're not sure if the value exists. It might exist or it might not exist. So just a way to emphasize the fact that maybe there is an element, maybe it's not, so be careful. And that optional type, we can see that it has or else. So, or else what it's going to do is that it's going to throw an exception if it doesn't find the element that we are searching for. So, or else throw. And what we want to throw in here is an exception. We can throw any exception, but let's throw an exception that emphasizes the fact that nothing has been found. And the way to do that when dealing with HTTP services is using status codes. And there's a specific status code that is 404 or not found. And Spring has a very convenient way of handling that. So what we can do is just create a response status exception. And in here we can send an HTTP status not found code. And that's probably going to be it. So this piece of code is first going to filter by ID. And if it finds it, it's going to return it. But if it doesn't find it, it's going to throw that exception that is going to be converted into a response with a status code of not found. So let's restart the server and see if things work. So after restarting the server, we are not going to do the to-do, we're going to the terminal. And let's start by an ID that exists. So we know that one exists. And indeed, this is the corresponding task to the ID 1. Let's try 2. 2 works as well. But if we try 3, you're going to notice that we've got a 404 status. And Spring is smart enough also to return some form of a response body for us. So it will auto-generate this response body where we have the timestamp, so when the error has occurred, what is the status code, what is the error, what is the method, and what is the path that we've used, so that the client can handle that error correctly. So that looks all nice, but as you can see, as we're going to add more operations to our to-do application, our controller is going to grow bigger and bigger. Right now it's pretty simple, it's pretty small, but once we start adding validation, once we start adding different users and different filtering mechanisms, different sorting mechanisms, then we add additional fields to the tasks, and that this class will get bigger and bigger and bigger. And therefore we should try to separate the concerns. So as we see, there's basically the response of like storing the tasks and also of like getting a task by ID, getting all the tasks. We need to form some form of an abstraction over that. And it's common to define what is called a service class, which the controller can use to do these operations. And if you remember also from the individual project, it might be hard to test classes that interact with user input. So the same applies to a task controller. It's possible to test it, but it's easier to test a simple class that just has simple methods, that doesn't have like these request mappings, that you don't have to like route requests and do all of these different things to test it. So if we separate the controller from the service that handles all that logic, we can have a better separation of concerns and cleaner code. So let's see if we can do that. So we're going to create a new class, and we're going to follow the same convention, the name of the model, and then service. And in here we're going to have basically two methods. So one method for getting a list of tasks and another one for getting a single task. Actually, what I'm going to do to start with, I'm just going to copy everything and delete the things that I don't need. So task service, just okay. I'm going to need this. I'm going to need this. But I'm not going to need to have request mapping annotations or the path variables, right? And probably not going to need these imports as well. So actually, instead of returning the status exception in here and throwing it, what I'm going to do is I'm going to return the optional type. Because as we've said, we want to separate the concern of, I also need to import it, Java util, because as I've said, we want to separate the HTTP related layer, everything that is HTTP related from our service. So if we like, we can create a command line interface and basically use the task service. Maybe we can use WebSockets or any other transport protocol other than HTTP. And if we have a well separation between the controller and the service, then we can reuse it to build a lot of different interfaces. So in that case, we don't need to return or else. So we're gonna remove that part because find first is going to return optional. So that's basically everything we're gonna need to do in here. Remove unused imports as well. So let's see how we can use that class inside the controller. So we no longer need a task list and a list of tasks. We're gonna get them from the task service instead. And as you can see, our controller will become much more smaller and much more cleaner in the process. So that class is going to depend on the task service. So let's add it as a field. Task service, let's call it task service. And in here, what we can do is like create a new task service. And that would definitely work. Let's go with that way first, and then I will show you a different way, which is a bit more cleaner and will work better once we start adding more complexity to the task service. So in here, instead of returning the task list, I will ask the task service to get me a list of tasks. And in here, instead of filtering the task list on my own, I will ask the task service to do it for me. So I will just pass in the ID. And already you see the controller has become much more cleaner. So let's see if that is going to work. So let's restart the server and go to the terminal and let's try to get it. Okay, if we get a single task by ID, it seems to work. If we get all the tasks, it seems to work as well. So if we try to get a task that doesn't exist, we get a status of 404 with a beautiful message from Spring Boot as well. So everything seems to be working, but we notice that the controller has become much more smaller, and the task service, it's a very simple class, so we can easily write unit tests for it, because it's harder to create, for this class we need to create integration tests, right? Because it uses the HTTP specific annotations, so it's harder to write unit tests for controllers. Whether for this class it's much more easier. So I will remove this unused import. And yes, so what I wanted to show you was the different way of creating the task service. So there's this concept that is called dependency injection in object-oriented programming languages, which kind of solves the problem of class creation and dependencies. So imagine that this task service, as we create the real implementation, it's gonna have its own dependencies, right? So it's probably gonna need to take maybe a repository, maybe it's probably gonna need maybe a database connection, maybe it's gonna need some configuration, maybe it's gonna need access to some external API wrapper, and so on and so forth. And then every class that needs to create that service needs to know how to create a repository, how to create a database connection, how to create a configuration object. And then these classes have also their own dependencies. So when you want to create a new repository, you'll probably want to create like a lot of different other things in here. So you can see how this graph of dependencies can grow larger and larger, and we're pushing the complexity to the user of the class of how to create them. The user for the class, you just want a task service. It doesn't care how it's created. So that's where dependency injection comes into the scene. So what we can do is just basically say that to Spring to automatically create that service and basically pass it in. And to do that, we use the auto-wired annotation. But in order for the auto-wired annotation to work, we also need to add an additional annotation for the task service. And it's common to use, if it's a service, it's common to use the service annotation, but there will be other annotations that we will be learning about. So we're telling Spring that the task service is a service. So if any other class needs it, just create it for them and pass it in. So in here, we don't need to do anything else than just write the name of the class and the name of the variable. And adding the auto-wired annotation will automatically create the service for us. And if there are any other dependencies that this service needs, auto-wired will automatically handle them for us as well. So that's a very cool concept. But let's see if that even works. So let's restart the application. So let's go to the terminal, and if we try to get the first task, the second task, the list of tasks, all of these different endpoints are working. If we try to get a task that doesn't exist, we're also getting the status code and everything. So Spring has automatically created a task service and passed it into the controller, which is pretty cool. So that's probably going to be everything for this tutorial. Thank you very much.